In question 7 part A, we need to differentiate this function. There's two ways of doing this, so I'm going to show you both ways. One way is to multiply out the brackets, so it's x squared minus x cubed e to the minus 2x, and then to differentiate using the product function. So let's differentiate the first bit. X squared differentiates to 2x, and 3x cubed differentiates to 3x squared. And then let's leave x squared minus x cubed alone and differentiate e to the minus 2x, so we get this. Now they want this written as e to the minus 2x multiplied by a particular function, so let's take out e to the minus 2x. That's right, so we've got 2x minus 3x squared, then we've got minus 2 times x squared, and minus 2 times minus x cubed, so that's plus 2x cubed. And then obviously this tidies up. Let's write the highest power first. We've got minus 5x squared plus 2x. So therefore f of x equals 2x cubed minus 5x squared plus 2x. There is another way of doing this, so I'm going to do this on the next slide. So another way of getting the same answer is to again multiply it out and then multiply out again. So it's x squared e to the minus 2x minus x cubed e to the minus 2x. So therefore g dashed x is, well, we've got two lots of product rules, so x squared goes to 2x, and then we've got x squared minus 2 times e to the minus 2x. Then we've got a minus sign, and then we've got another product, so that's 3x squared e to the minus 2x plus x cubed, and then minus 2 times e to the minus 2x. So e to the minus 2x is everywhere, so I've got a 2x here, and I've got a minus 2x squared there, and I've got a minus 3x squared at this point, and a minus 2 times minus, that's a plus 2x cubed at this point. So let's tidy up. We've got 2x cubed minus 5x squared plus 2x. So f of x, which is what they're after, is 2x cubed minus 5x squared plus 2x, which is the same as we had before. Now in part B, we're after the range, so what we want to know is this point here, the y value there, and the y value there. And obviously at these points, f dashed x equals, or sorry, g dashed x equals 0. So this is g of x, so at those points, g dashed x equals 0. So g dashed x equals 0 means that e to the minus 2x multiplied by 2x cubed minus 5x squared plus 2x equals 0. Now e to the minus 2x doesn't equal 0, it can't equal 0, so we're left with 2x cubed minus 5x squared plus 2x equals 0. X is a factor, so we're left with 2x minus 1 and x minus 2 equals 0. So therefore x is 0, 1 half, or 2. So this point here is 0, this point here is a half, this point here is 2, so the range is between x is a half and x equals 2. So when x equals a half, g of x is x squared, that's a quarter, 1 minus x, that's a half, and e to the minus 2x, 2 times minus half is minus 1, so that's e to the minus 1. So that's 1/8 e to the minus 1. when x equals 2, g of x is x squared times 1 minus x, 1 minus 2 is minus 1, times e to the minus 2x, that's e to the minus 4. So we can write that as minus 4e to the minus 4. So the range is minus 4 over e to the power 4 is less than or equal to g of x is less than or equal to 1 over 8e. Now in part C they're asking why g minus 1 is not a function, and any one of these three answers would be acceptable. You could say the original function g of x is not a one-to-one function, or you could say it is a many-to-one function, or you could say the inverse would be a one-to-many function. Remember, a function given one particular input can only have one output, so you can't go from one number and have two or possibly more than two answers. So any of these answers is acceptable for the 1 mark in part C. For question 8, we've got to prove the trig identity which is this. 1 over sec 2a is cos 2a, tan 2a is sin 2a over cos 2a. So 1 plus sin 2a over cos 2a, and then let's convert everything to single a's because the right hand side has single a's, and it's not clear which formula we should use at this stage. Let's hedge our bets and use the one with both cos and sine. Now the right hand side has cos a minus sine a at the bottom. So I could write the denominator like this. So I get to this stage here, it's not immediately obvious what to do. There is a little trick where you can write 1 equal to cos squared plus sine squared, and then the whole thing factorises. But if you don't see that, let's think of an alternative method. So let's consider the right hand side, which is cos a plus sine a over cos a minus sine a. Now the previous left hand side that we had cos squared minus sine squared. So let's make the denominator cos squared minus sine squared by timesing top and bottom by cos a plus sine a. The reason I'm doing that is because now the denominator is cos squared a minus sine squared a, which is what we had on the bottom of the left hand side. Let's now expand cos a plus sine a squared. That's cos squared a plus sine squared a plus 2 sine a cos a. Cos squared a plus sine squared a is 1. So now we've got the left hand side that we had before. So that completes our proof. Now in part B it says hence, which means we can use the result we've already got. We know that sec 2 theta plus tan 2 theta equals cos theta plus sine theta over cos theta minus sine theta, and that equals a half. Even if we didn't successfully complete the proof in part A, we can still use the result. So 2 cos theta plus 2 sine theta equals cos theta minus sine theta. Let's gather together the cos thetas. Let's gather together the sine thetas. Now we can divide by cos theta, divide by 3, so we get tan theta is minus a third. And solving that, and using the fact that we're in radians, we get theta is 2.820 and 5.961. We need it to 3 decimal places. Now we've got question 9, and we need to simplify f of x, so it's 2 minus x minus 5k x minus k, and then the denominator there factorises to be x minus k x minus 2k. So the x minus k's cancel, and then we can write everything over x minus 2k. So it's 2x minus 4k minus x plus 5k. Be careful there, we've got a minus sign there makes a plus. So that's x plus k over x minus 2k, proof complete. In part B, we've got to differentiate. Nice easy quotient rule. Let's differentiate the top one first, that's 1, and leave the bottom one alone. Let's differentiate the bottom one second, that's 1, and leave the top one alone, and it's all over the bottom one squared. X minus x is 0, minus 2k minus 1k is minus 3k, over x minus 2k all squared. This just goes to show that just because it's the last question on the paper doesn't mean to say it's the hardest question. Part C is a little bit trickier, because we've got this expression for f dashed x. We know that the denominator is positive for all values of x. Okay, because if you square any number, positive or negative, the answer is positive. And since k is negative, which we're told at the start, minus 3k is positive. Therefore f dashed x is positive, since a positive number divided by positive gives a positive answer. So since f dashed x is positive, therefore there must be an increasing function. Since the gradient is always positive.